So with that, let's welcome our first presenter, Manuel Oum from Edis Research. So let me wire you up, because even though we believe in wireless, we have to go like wired, right?
Naturally.
So, I'm not sure where you want. Like usually, it should be on the part of the belt farthest away from cellular devices. Right?
Oh yeah, well yeah.
Technology.
You don't want GSM interference, wireless interference. Absolutely. What's that? I've never heard of that. Okay.
And again, all these presentations except the MediaTek presentations, 20 minutes. So we'll try and keep the schedule.
All right. So thank you, and good morning. Let me get this going. Filling out that speaker form was really interesting. The implication is that they're going to broadcast this on SiriusXM, I think, multiple TV stations, YouTube, it's social media, it's all good.
Translated into 5 different languages.
Yes, I think Sanskrit was one of the, anyway. All right, so can everyone hear me okay? Yes? Okay, good. All right, so we're at New SDR. I guess I have to talk about new SDRs. But first, I thought I'd talk about a little perspective, industry challenges. For those of you who have been in the SDR industry for a long time like I have, you might realize that SDR customers can actually be a little demanding. I know none of you are, but some of them can actually be a little demanding. And so, what does a day in the life of Edis look like, especially when we're talking roadmaps and futures? Well, of course you need more bandwidth. Everyone needs more bandwidth. But of course you have to do that while lowering latency. Not a problem, right? Easy problems to solve. We like easy problems at Edis. The SDR community loves the easy problems. Some folks want increased throughput that comes with the increased bandwidth. Imagine that. But of course, most people don't like having ovens on their desk when they're working. And for some reason, they seem to want it fairly inexpensively. I don't know. Sure, we can do that. How about the folks who want higher frequencies? Millimeter wave, right? 5G, we're talking 28, 39 gigahertz. Sure, how hard could that be? There's folks, we have systems going up to 70 gigahertz at the moment within National Instruments. But of course, military folks here in the room, you want lower frequencies. Everyone wants to do HF, right? HF is back again. So you have to have higher frequencies and lower frequencies. Okay. More channels. But of course, those channels, of course, they have to be phase coherent, tightly synchronized. Again, sure, throw more challenges at us. Dynamic range. I think I was talking to some of you in the room about dynamic range and SFDR earlier this week. Always a challenge. And actually with SDRs, it can be a pretty interesting challenge because we're not trying to build really expensive NIST-calibrated instruments, right? There's very expensive test equipment for that. I find really fascinating when we talk SDRs with folks and roadmaps, the first thing everyone wants to talk about is hardware. But it's called software-defined radio. I find that really interesting. But I actually think software is, of course, where the power and the value of SDR is. And so there are folks that want increased reliability and increased security. That's a combination, of course, of hardware and software features. And I know everyone in this room loves a challenge. But believe it or not, there are actually some people out there who want to have their development and design time be easier, be faster, more productive. It's hard to believe, but there are those folks out there. They want the tools to do that. They want the reference designs. I think I've made this joke a couple times already this week, but I used to work at Xilinx for 6 years. Oh, this is recorded. Oh, anyway. I worked at Xilinx for 6 years. Never once did I get complimented on the tools, very honestly. But, Xilinx, great company, great FPGAs, just hard to program, right? And their tools are actually getting a lot better. But, yeah, compared to writing C, C++, Python, it's not quite there yet, right? And, of course, size, weight, and power. You have to do all that in a, little thing about the size of a credit card, right? So, again, how hard could that be? Trying to plan out the roadmaps and futures for Edis Research and for any company doing business in the SDR community can be a little challenging. Of course, there is a very simple answer. All this can be solved with the new Edis Research X10000, which will be available tomorrow. You should all write that down. No, don't write that down. Physically impossible, right? Physics will not allow all this to happen. However, it's a discussion around trade-offs, right? And that's always inevitably the discussion we have when it comes to roadmap discussions. And I will be very happy to discuss trade-offs with folks throughout the rest of the day. can't have it all, but as we talk about some of these new products coming out from Edis Research, the new USERPs, you are going to see some of the trade-offs, the outcome of some of the trade-offs that we made based on customer feedback from folks like yourselves and many other customers that we have. So the first one I thought I'd talk about, this one's actually available today, but I think the word hasn't quite spread to everyone out there in the community, so hopefully some of this is new to some of the folks here in the room. And you'll see the tagline for the N310. We actually have one out in the front, and if anyone can get it running, by the way, I'll pay them $10,000. I mean that. It's a mechanical sample. But anyway, but we have started shipping these. The tagline, as you can see, is simplifying SDR deployment. Okay, so what does that mean? Even that tagline implies that we made certain trade-offs versus other trade-offs, right? So from a hardware perspective, because again, it's software-defined radio, you want to know about the hardware. We did build features around reliability, fault tolerance. I'm going to come to that. But from a hardware perspective, we are increasing the channel density. So with an X310, you can get up to 2 channels, 2x2. This device allows you to go 4x4. It's a little longer than an X310, but otherwise similar size, 1U high. It has a large user-programmable FPGA. It's actually got a Xilinx Zynq 7100, so that's the largest FPGA in the Zynq family. Gives you the ability to run full embedded standalone mode because you have the dual ARM Cortex-A9s, as well as the FPGA fabric. We have dual SFP+, so you can do full streaming of the bandwidth. And you have, again, in this particular device, you have 4x4, at 100 megahertz bandwidth. I'll talk more about that in a minute. From a synchronization perspective, so I mentioned synchronization before. We have the standard GPSDOs, clock PPS. We actually added another feature called White Rabbit. It's actually based on an open source implementation that gives you precision timing. It's essentially a PTP implementation. So I'll talk more about that, but we had a lot of customer feedback on having very precise synchronization and also potentially in denied GPS environments. Things like self-reset watchdog timers, I'll talk about that more in a minute. So from a software experience, there's 2 ways you can run it, typical of most, the E-Series, for example, from the USERP family with the Edis. You can run in embedded mode, where you have to use the ARMs. Dual Cortex A9s, 667 megahertz. Actually, no, these ones I think run at 800 megahertz. So definite limitations on compute horsepower, but for folks looking for size, weight, and power, that does give you very nice option versus having to have a host computer. But of course, if you want to fully stream to the host computer, do offline or somewhat soft real-time processing, that's also available. Okay, let's talk about remote management. So this is actually the stuff that for me is the most interesting in terms of the feature set that we've incorporated into USRPs. And this is actually something that will carry forward with all future generations of USRPs. So we're not going to backport it, but for all next generation USRPs, these features are all built into UHD and supported within UHD going forward. UHD, for those of you who don't know, is the USRP hardware drivers. So we give you a way to consistently manage a remote network of devices. It allows you to do things like reboot remotely, do things like reset to factory default settings remotely. You can do firmware upgrades, OS upgrades remotely, do system health monitoring. So we talked earlier about thermals, right? You want to be able to manage the thermal system, and usually it's the FPGA and the ADCs and DACs that are consuming the most power. So you'll have the ability to monitor the temperature on those and do self-corrections for IQ imbalance and DC offset. So for me, this is actually really powerful, and that talks to the deployment message that I talked about earlier. Being able to put this out there with multiple of you out there. I know you're building test beds, for example, where you're going to have things mounted remotely. Some of you might be building remote radio heads. You're going to have those, again, outdoor mounted somewhere. And some of you might be building small form factor defense systems where you want to deploy those in the field, and you don't want to have to go to the unit to do any kind of debugging. So this gives you that ability to do that. So let's come back to the hardware. On the hardware, we're leveraging the Analog Devices 9371, so otherwise known as Mykonos. It's the next generation to the 9361, the Catalina device. And on this particular device, we have 2 of the 9371s. So there's also an option for 1, which would be 2x2, but there's also an option for 2 daughter boards, which is the N310. So you can do 4RX, 4TX, 100 megahertz of bandwidth, independent tuning across the transceivers, and actually what's notable as well is the RFIC actually goes from 300 megahertz to 6 gigahertz, but we've added a block up and down converter so we can actually go down to 10 megahertz, so that's part of the getting down to lower frequencies. And the sample rates are basically, besides some legacy rates, are also supporting the 3GPP rates, because we have a lot of customers that are doing research on 5G and other wireless technologies. So we talked a little bit earlier about reliability and security too. So also, for the first time in USRPs, we've added what's called a TPM, which is a Trusted Platform Module. So for those of you not familiar with that, that basically allows you to create a root of trust on the device. Okay, that will manage all the keys, authentication, and allow you to do secure reboot or updates to the hardware. In terms of FPGA resources, like I mentioned, with the N310, we've gone to the Zynq 7100, which is the largest in the Zynq family. Gives you a lot more to work with than the X310, certainly a lot more than the E310, for those of you familiar with those devices. And then I mentioned before, we do have a 2x2 option. So that's the N300. It's a lower cost alternative. It's 2x2. As you can see, instead of the Zynq 7100, it uses a Zynq 7035. Okay, so smaller device. Other thing to note is that in terms of extended temperature, the N310 is an I-grade FPGA. The N300 is C-grade. So you're going to get also better extended temperature with the N310. And other than that, most of the other things are fairly similar. One other difference I should actually put on this chart is there is no TPM in the N300. So if you want that root of trust from the Trusted Platform Module, you'd need the N310. Okay, talked before about synchronization. So synchronization, very important, and going forward as you see more systems being remotely deployed, you're seeing things like massive MIMO, where coherency and phase alignment are becoming pretty much mandatory. We saw a need to increase the bar on synchronization. In the commercial space as well, we get asked quite a bit about support for CPRI. And CPRI is not the easiest standard. It's loosely defined as a standard to support in any device, let alone USRPs. And so we wanted to come up with a simpler solution than that, and one that's easier to implement. And where the industry was trending towards was IEEE 1588 running over synchronous Ethernet, right? Because Ethernet is pretty much ubiquitous. So this White Rabbit is an open source implementation. It was actually developed at CERN. And it gives us the ability to have sub-nanosecond skew and sub-picosecond jitter. Actually, far better performance than actually defined by the IEEE 1588 spec. And you can, of course, support over up to 10 kilometers. In that case, you have to use fiber, of course, and scalable beyond 2,000 nodes. All right, so this is a new feature. This is not going to be on all USRPs going forward, but it is available on the N310 and the N300. We have partnered with a company called 7 Solutions, where they provide the switch and the master clock reference, and you virtually plug the USRP, the N310 in, and it pretty much works. So we'll actually be publishing a white paper on this probably in the next week or so. So if you're interested to learn more about White Rabbit, you can read our white paper, and you can also go check out literature on the CERN site. Okay, remote software updates. So again, back to the software side, the deployment features. So in this particular case, we leverage a set of tools called Mender and Salt, of course also open source, available under the Apache 2.0 license. And so we wanted to leverage that. It gives us nice modularity, maintainability. Of course, you know, there is also a whole open source community as well around Mender and Salt, and we wanted to be able to leverage those. It gives you a client management server type architecture, and works great with the embedded images and Yocto that we run on the Zynq devices. So create new software. You have a server that can update multiple devices. I'm actually not sure what the limit is off the top of my head, but you can have a pool of many, many devices that are all remotely managed by the server. do status updates, pull it. And we also have a dual redundant partition scheme available through that, so that as you're doing updates to your firmware or OS, you have the ability to either commit to the install or do a rollback if there's some particular issue for some reason. So that's nice, and it's all managed with cryptographic keys. So again, back to the reliability, the security, the things that for folks looking to deploy in the real world are important to them. All right. So that's the N310. I think I've got, 5 or 10 more minutes. So let's go to another device. This device is not available yet. You see there the availability is targeted to be early Q4 2018. It's called the E320. We have discussed this before at GRCon. And really the tagline here is expanding the E-Series family. So what does that mean? Well, expansion can mean a number of different things, of course. Adding more devices to the portfolio. Yep, sure, that's one. But also one of the biggest items of feedback we've gotten on the E310 is that the FPGA is too small. So we're looking to resolve that problem, and that's what the E320 is for. So to the heart of the problem, you can see the E320 uses actually the smallest zinc, the 7020. We've now upgraded that with the E320 up to a 7045. So a lot more resources available in the FPGA, as well as, of course, the use of the dual ARM Cortex-A9s as well, so you can run in full standalone embedded mode. So that picture there is actually the first one that came off the production line, so we have hardware. Things are going very well in the development of it. Some of the new features you can see that we've added to address other shortcomings that we've found out with the E310. One is an SFP Plus connector. Right? So on the E310, you had 1 gigabit Ethernet. Okay, theoretically, you have the analog devices 9361 with 56 megahertz of bandwidth, but there's no way to stream that to a host PC. Maybe you can get 20 if you're lucky and doing really well. So with the SFP Plus connector, you can run 10 gigabit Ethernet or Aurora and stream the full bandwidth of the 9361. There will be 2 versions, a board-only version, and there will also be one with a passive cooling enclosure. We are targeting environmentals around 0 to 50 degrees C, somewhere in that neighborhood. So unlike the X310, which was kind of designed to be, hey, benchtop 25 degrees C, we're actually building much more in terms of environmental characteristics for both extended temperature but also shock and vibe. Speaking of shock and vibe, you'll notice it's a monolithic PCB. So unlike the E310, which has a motherboard-daughter board architecture, this is a single PCB, which also makes it more robust, can survive in more rugged environments. We put the temperature sensors on there as well, again on the 9361 and the Zynq FPGA for reliability and monitoring purposes. Of course, to be portable, you can connect it to a battery as well if you want to. There won't be an E312 type version, but you can easily buy external batteries that you can plug into the barrel jack to have it run on battery. Size, weight, and power. Okay, so the E310, love the size of it. It's about this big. With the E320, unfortunately, there is no way to get it into that small form factor. So the form factor will be 3U Eurocard size, which if any of you have a B200, that size. Still quite compact. The FPGA, of course, is much larger, so you can see that alone prohibited the use of the same form factor as the E310. In addition to that, of course, we wanted to have GPSDO. We also thought people might have some fun with a MEMS gyroscope. So I'll be interested to hear what kind of fun stuff folks do with that. But a lot of the applications that we're targeting, you can see a list here, SIGINT, spectrum management, but a lot of interest as well from companies doing drones, drone defense, and so clearly we've targeted a lot of features to enable that type of customer base. Quick block diagram. I'm not going to go over most of this. You'll have the slides to review later. But again, you'll also notice there's a TPM. So it's the same TPM as the N310. So again, you have that root of trust in a deployed device. You have the temperature sensors. You have the larger Zynq, the GPX SDO, and the higher speed SFP Plus interface. And with that 1-minute warning, thank you. I invite you to come see our demos. I don't know if you want folks to take any questions now, Alex, or just...
Probably during the network.
All right. Moving on then. All right. Thank you for your time, and I hope to talk to you later at the show.